The morning felt heavier than usual. Instead of drills or splices waiting on the benches, Harris rolled out a large sheet of paper. On it was sketched a workshop. Rows of outlets, overhead lights, and a heavy table saw drawn at the center. "This," Harris said, tapping the paper with his pencil, "is your first design challenge. Until now, you've pulled wires and followed instructions. Today, you decide the circuit itself. This is the burden of numbers." Maria leaned in, studying the drawing. "So we're designing, not just wiring." Harris nodded. "Every wire you pull is born from a calculation. Branch circuit is the path from the panel to the load. If your numbers are wrong, your wires overheat, your breakers trip, or worse, someone gets hurt." The foreman appeared behind him, holding a breaker in one hand. His voice was sharp. "Tell me, apprentice, what is ampacity?" I swallowed, then answered. "The maximum current a conductor can carry safely." We dropped the breaker onto the table with a thud. "Correct. And what happens when your load is greater than the ampacity?" "Overheating. Fire," I said. The foreman's eyes gleamed. "Good. Remember it. Fire doesn't forgive bad math." Harris turned back to the sketch. "The workshop needs 3 things: lighting, receptacles for tools, and a dedicated circuit for the table saw. You will calculate the branch circuits, choose the breakers, and select the wire sizes. Begin." Maria's pencil scratched across her notebook. 12 receptacles at 180 VA each. That's 2,160 VA. At 120 volts, that's 18 amps. So we need a 20 MP circuit. Harris nodded slightly. And she paused. "Because it's a continuous load, we must size at 125%. That's 22.5 amps. A single 20 MP breaker isn't enough. We'll split them into 2 circuits." Harris smiled faintly. "Well done." Kev frowned at his own paper. "Overhead lights. 12 fixtures, 150 watts each. That's 1,800 watts. At 120 volts, that's 15 amps. So a 15 amp breaker should be fine." The foreman's eyes narrowed. "And if those lights are on for more than 3 hours?" Kevin hesitated. "Continuous load, and multiply by 125%. That's 18.75 amps. So the 15 amp breaker fails. We need a 20 MP. The foreman gave a rare nod. "You learned slowly." I studied the saw at the center of the plan. Its nameplate read 3,600 watts at 240 volts. My pencil trembled. "That's 15 amps running load. Add 125% for continuous, use 18.75 amps. But startup surge could be much higher." Harris's eyes met mine. "Correct? Motors demand more at start. Breaker must handle both running load and inrush. What size will you choose?" 30 amps with 10-gauge wire, I said, more confident now. Harris smiled faintly. "Good. Safe. Conservative. That is design." Kevin groaned, frustrated. "Why can't we just oversize everything? Bigger breakers, thicker wires, no problem." The foreman's voice cracked like a whip, "'cause oversizing is as dangerous as undersizing. Too large a breaker and the wire burns before the breaker trips. Too thick a wire and you waste copper, money, and space. Discipline is balance." Maria muttered softly. "Every number carries weight." Harris heard and nodded. "Yes, that is the lesson. Numbers are not abstract. They are life and death." We spent the next hour crunching numbers, writing them in columns, checking and rechecking. For the first time, wiring didn't feel like labor. It felt like solving riddles that could burn houses if answered wrong. At last, Harris gathered our notebooks, lighting 2 20 MP circuits, receptacles, 2 20 MP circuits, table saw, 130 MP, 240 volt circuit, balanced, compliant, safe. The foreman added, his tone grave, "And remember, this is only a sketch. On a real site, inspectors will demand to see your calculations. They will check your loads, your breakers, your conductors. Fail once, and they will never trust you again." Kevin sighed, but even he looked humbled. The weight of numbers had pressed into all of us. Harris closed the plan with a decisive hand. "Tomorrow, you will face a harsher trial. It's not just numbers on paper, but balance across phases. Circuits that must not only carry the load, but share it, divide it, dance without tipping the system into chaos. The foreman's voice rumbled like distant thunder. Next episode, the balance of phases. The next morning, the workshop plan was still pinned to the wall. Circuits and numbers filled the page lighting, receptacles, and the saw. We thought we had conquered the math. But Harris's face told us otherwise. He stood silent, arms crossed, until the door opened and a new figure stepped inside. The inspector, who wore a gray jacket, his eyes sharp as knives, clipboard in hand. He didn't greet us. He simply studied the plan for a long moment before speaking. "This design," he said flatly, "will pass no inspection." Kevin blinked. "But we calculated everything. The loads are right. Breakers are sized. Wire gauge is correct." The inspector's voice was ice. "Correct numbers, wrong balance. Look here." He tapped the drawing with his pen. Lighting, receptacles, and the saw crowded on 2 phases. The third phase nearly empty. "Do you want the panel to groan under imbalance?" Maria frowned. "So, even if the loads are right, if they're not balanced it fails." Harris nodded grimly. "Yes, an unbalanced system overheats neutrals, wastes capacity, and can cause voltage swings. Balance is discipline. Balance is survival." The foreman barked. "Prentice, what happens if one phase carries too much and the other's too little?" I steadied my voice. "The neutral current rises. Lights may flicker. Motors overheat. Equipment fails." The inspector's eyes locked on me. "Correct. And inspectors will re-tag it on site." Kevin muttered under his breath. "So we're jugglers now? Balancing numbers like circus balls?" The foreman's glare silenced him. "It's not circus. War. Balance keeps the system alive." Harris unrolled a fresh sheet of paper. "We redesign. Lighting circuits split. One on phase A, one on phase B. Receptacles divided. One on B, one on C. The saw takes phase A and C at 240 volts. Demand factor applied. Voltage drop within limits." Maria leaned in, tracing the new plan. "So each leg carries near equal current. The neutral rests instead of screaming." The inspector nodded once, the faintest approval. "Better." Harris wasn't finished. He tapped the saw circuit. "Voltage drop. The run is long, 100 feet. At full load, the drop is too high if you use number 10. Upsize to number 8 to keep it within 3%. I scribbled notes furiously. "So even correct breakers and balance fail if voltage drop is ignored." "Exactly," Harris said. "So code is not just about avoiding fire. It is about efficiency, stability, and longevity." The inspector asked suddenly, "What is the demand factor for receptacles in a workshop?" Maria answered quickly, 50% after the first 10. The inspector studied her, then nodded. "Good, you know your tables?" Demand factor reduces oversizing. Without it, copper is wasted. With it, you design lean but safe. Kevin raised his hand reluctantly. "So balancing isn't just even splitting. Splitting smart. Using demand factors, upsizing where needed, downsizing where allowed." For once, the foreman's face softened. "At last you understand." The inspector stepped back, folding his clipboard. "Remember this. Balance is not an option. It is the first thing I check. Unbalanced work is failed work. Do it right, and I sign. Do it wrong, and you start over." With that, he left boots echoing down the hallway. The silence he left behind was heavier than any breaker. Harris spoke quietly. "You see now? Numbers alone are not enough. Balance is the hidden law. Ignore it, and even perfect math collapses." Maria nodded. "Every circuit is part of a dance. If one stumbles, all fall." Kevin exhaled. So much for shortcuts. The foreman's voice rumbled like thunder. "Tomorrow, you face the surge. When motors start, when saws roar, when currents leap higher than you planned, that is the next trial." I felt my chest tighten again. No numbers had nearly crushed us. Balance had humbled us, and now, Harris promised, power itself would surge against us. Next episode, the surge of power. The air in the shop felt restless that morning, charged with tension before a storm. The plan from yesterday still hung on the wall, balanced across phases, neat and precise. But today Harris rolled in something new, a heavy steel table saw, its blade gleaming under the light like the fang of a beast. "Numbers are fine," Harris said, resting a hand on the machine. Balance is fine, but real power does not live on paper. It surges, leaps, and tests your circuits. Today, you meet the surge of power. Kevin grinned nervously. It's just a saw, right? We wired a 30 amp breaker. Number 10 conductors. Should handle it. The foreman's voice cracked like thunder. Should is for gamblers. Circuits demand certainty. Maria leaned closer, reading the nameplate on the saw's motor. Full load amps, 15. But, she frowned. Locked rotor current 90 amps. Harris's eyes gleamed. Yes. At startup, the motor draws 6 times its running current. That is the surge. The circuit must withstand the inrush without tripping instantly, yet still protect against true overload. Balance between mercy and discipline. The foreman barked, "Power it. Show me your design can stand." My hand shook slightly as I threw the disconnect. The saw shuddered, the motor groaned, then roared alive. For an instant, the lights overhead flickered, breakers buzzing like hornets in their sockets. Then darkness. The breaker tripped with a brutal snap. Silence swallowed the room, broken only by Kevin's muttered curse. The foreman's glare cut into us. Kevin tried to defend himself. The breaker was 30 amps. The wire is number 10. It should have worked. Harris's voice was quiet, but sharp as a blade. You designed for running load. You forgot the surge. Maria opened her notebook quickly. So, we must allow for inrush. But oversizing the breaker too much risks letting wires burn. How do we solve it? Harris pointed to the overload relay inside the starter. This protects against sustained overcurrent. The breaker protects against faults. Together they allow inrush but stop danger. That is why coordination matters. The foreman leaned in close, voice low and dangerous. And what about derating? You packed multiple conductors into that conduit? Heat rises and passivity falls. Did you reduce capacity in your math? My heart sank. It hadn't. Maria whispered, so our 10 gauge might only carry 24 amps safely in that bundle, not 30. The foreman slammed his clipboard on the table, you see. Numbers on paper lie when you forget reality. Heat, distance, surge, demand, these are the hidden enemies. We rewired quickly, separating the saw circuit into its own conduit. Maria recalculated with derating applied, choosing number 8 instead of number 10. Harris nodded approval. Now test again. I flipped the disconnect. The saw growled. The lights dimmed but held. The breaker trembled but stayed firm. The blade spun, steady and fierce, chewing the air with a metallic scream. Maria's smile broke through the tension. It works. Kevin exhaled in relief, so close to failing again. The foreman wasn't done. He stepped forward, voice booming. Remember this trial? Circuits must be designed not for calm, but for storms. Inrush current, continuous load, derating, demand factors. If you design for the easy path, you kill machines. If you design for the hard path, you save them. Harris placed his hand on the roaring saw, then shut it down with a flick. The silence after was as sharp as the blade itself. This is the surge of power. Never trust calm numbers without testing their fury. Electricity will always reveal the truth. For a moment, none of us spoke. The weight of the lesson pressed deeper than any calculation. Then Harris's tone shifted, darker still. Today you faced a surge and lived. Tomorrow you face something harsher. Not just power unleashed, but power gone mad. Circuits fail, machines run wild, and only one thing can save you. The foreman stepped closer, his eyes cold. Emergency stops, the shield of last resort. Miss it once, and men die. Maria shivered. Kevin swallowed hard. My chest tightened with anticipation and dread. Next episode, the test of emergency.